All right, picking up where we left off here with number 12. What is the equation of the perpendicular bisector of a line with endpoints 0, 6, and 8, 2? So first thing we have to do here, and one of two things. We need the midpoint of that line segment, okay? And we also need the perpendicular slope of that line segment. So what's the slope? And then what would be the slope that is perpendicular to it? That's what we need here, okay? So we're going to look for those two things. So the midpoint, remember, is the average. We add the coordinates, so 0 plus 8, or 8 plus 0, and divide by 2, and then we add the y's. So then 2 plus 6, we divide by 2. So that's 8 over 2, and 8 over 2, which is the 0.44. So that's my midpoint. The slope, remember, is y2 minus y1, so 2 minus 6 over the x's, and it's x2 minus x1, so that's 8 minus 0. And so this is our slope. So this is negative 4 over 8, which is negative 1/2. So the perpendicular slope is going to be the opposite reciprocal. So flip it over, we get 2, change the sign, and now it's positive. That's the perpendicular slope. So what we need now, we have the slope, so we know our equation is going to look something like y equals 2x, and then we don't know the y-intercept. So we're going to take the y equals mx plus b. We're going to plug in this point, because remember, the perpendicular bisector crosses through the middle of these 2 points, right in the midpoint. So it goes through the midpoint. So I can plug 4 in. I'm going to plug the slope of 2 in, and then I'm going to plug the x 4, and I'm going to go solve. So this is 4 is equal to 8 plus b. Subtract 8. We're going to get negative 4 is equal to b. And so now we know my equation is y equals negative, or 2x minus 4. Okay? 13, find the midpoint. So same thing, just add and divide by 2. So the x is negative 2 plus negative 6 divided by 2. And then the y's 4 plus 0 divided by 2. Doesn't matter if you go like the 6 first and then the 2, just be consistent. So if it's 2, the negative 2, then put the 4 first. If you do the 6 first, put the 0 first. Okay? So this is negative 8 over 2 and 4 over 2. And so this is negative 4, 2. Don't forget to use parentheses when you're doing points, okay? So make sure you're doing that one. Number 14, we have a vector. V describes the translation of the map's quadrilateral ABCD onto the quadrilateral A prime, C prime, A prime, B prime, C prime, D prime. So what they want to know here, magnitude, it essentially just means when you did your translation, how far, what's the distance that the shape traveled. So we want to know the length of this translation, this line from D to D prime. So you can either use Pythagorean theorem by looking at the rise and the run between the points. So you can see I'm going essentially up 3 and over 2. And so I can use Pythagorean theorem there. Or I can use the points. This is the point -9, -1. This is the point -7, 2. And I can use the distance formula. So it's totally up to you. If you're using Pythagorean theorem, it would look like this. Okay? And then you're going to end up with 9 plus 4. And that's the square root of 13. So that's the vector. Okay? That's the magnitude. Magnitude of V. If you're doing the distance formula, okay, it's going to be x2, so we can do like -9 minus -7 squared plus the y's, which is going to be, now I started with -9, so I'm going to choose that again. That's the y, -1, and then here I'm going to be -2. And so you can see you're going to get plus a positive. -2 squared plus -3 squared, and then we're going to be right back in that area. Okay? 15, if L1 and L2 are just two distinct lines that are parallel to another line, L3. So let's call this L3. So I have L1, and these two lines are parallel. Okay? And then I draw another line and call it L2, and these two lines are parallel. What do I know about L1 and L2 then? And if they're both parallel to L3, then they have to be parallel to each other. So it's choice B. Verse 16, which equation of a line represents a line that is parallel to this guy? So first thing I need to know is what's the slope of this line. So remember, we always have to get y equals first. So we'll add 10 to both sides, and we'll write it in the y equals form. So it's going to be x plus 10. We want to do mx first, and then divide everything by 2, and y equals 1/2 x. Remember, there's really 1 in front of the x there, and then plus 5. So our slope is 1/2. Then we want the slope of a line that's also 1/2. So if we just divide out, you'll see you get y equals 2x minus 3. That's out. Divide here, and you're going to get y equals negative 1/2 x minus 5. That's out because it's not the same. Divide by 2 here, and you're going to get y equals 1/2 x plus 3. Those are the same, so that would be my answer. And just to finish off, this one would be perpendicular because we'll get negative 2x minus 4, and those are opposite reciprocals. So for a perpendicular, we go with D, but here B is the answer. All right. 17, we have the Terry Fox Trading Company has been asked to give an estimate for the cost of a closing yard. It's in the shape of this weird polygon that's labeled A, B, C, D, E. Please make a note that point D, although it says 77, is actually 0.87. You can see it's over 8 units, not 7. And the yard drawn, apparently it's an abbreviation for drawn, to scale in the company diagram. It says the fence costs $9.95 per linear foot. So what we want to do here is figure out how much fencing we need. And this is essentially just the perimeter of our shape. And keep in mind as well that we're actually talking about a scale unit here. So each of these units on the graph is worth 10 feet. So if we end up with like 10 units in our distance, it would actually be worth 100 feet. So we can do the distance formula for each side, or we can do the Pythagorean theorem here and figure out the lengths of those sides. So I will let you guys pick your options. I'm going to go with the Pythagorean theorem option. However, just make a note as well that this line right here is already a horizontal line, and I can just count the units. So I know that that length is 7. Okay? So we know the length of AB is 7. So the distance of AE, all right, is going to equal the square root of, and you can see it's going from 1 to 6, so it's 1, 2, 3, 4, 5. So that's, we'll do that over here, that's y squared. So that's 5 squared, and then we're going over 2, and that's 2 squared. And so this is equal to the square root of 4 plus 25 is 29, and that's the length of AE. Okay, next thing we want is the length of, we'll do ED next. And so this is going up 1, and over 1, 2, 3, 4, 5, 6. So this is going to be 6 squared plus 1 squared. That's 36 plus 1. So this is 37, square root of 37 for ED. We have DC here, okay, which is down 3 and over 2. So, and if you want to go 2 to the left, it's like negative 2 essentially, right? So negative 2 squared plus 3 squared. And you don't have to do the negative. You can just do 3 and 2. It's fine. Because when you square it, it's going to come out positive anyway, so it's not going to matter. And this is going to equal the square root of 13. And the last one we need is BC. So BC is equal to the square root of, and it's 1 and 3. So 1 squared plus 3 squared. And this is the square root of 10. So the total perimeter is just AB plus AE plus ED plus DC plus BC. And so this is radical 29. Now notice I'm not using the decimals here, okay? I'm using the radicals, which are not rounded, all right? Obviously this should be pushed down, but you get the idea. So 7 should go here, radical 29, and then push all those down 1. Okay, and we're going to add those together, and P is equal to, let me go grab a calculator real quick. And so we just do square root 29, arrow over to get out of the square root. square root of 37 plus square root of 13 plus square root of 10 plus 7. Notice that is different than doing the square root of and then adding these numbers all inside of it, right? So you can't just do square root of the sum of the numbers and then just do plus 7. That's not going to give you the same thing, okay? These are taking the individual square roots. These don't have the same numbers inside of them, so I can't add those together, okay? So we should get 25.237. That's in the actual perimeter, but remember, there's a scale factor of 10. So when I take this, I have to remember to multiply that number by 10. And you can see it says to the nearest foot, so this is 252.35 feet. Okay, so this radical is actually 25.235756. Some other numbers. The actual feet, though, 25.235756 times 10. That's 252 feet, approximately. Don't round here and get 250. Round after you multiply 10, 10. And then for part A to get the price, it's $9.95 per foot. So we just take 252 feet, times it by $9.95. So 252, and we're at about 252 times 9.95. There we go. And that's $2,507.04. 40 cents, not 4.40. Okay? All right. Number 18, remember we made this change. We changed D to -4. So -1, -4, just keep that in mind. So A was 6 to the left, down 2. So there's point A. B was over 2 to the left and up 3. C was over 3 to the right and up 1. And D was over 1 and then down 4 to the left, down 4. Okay? So we want to prove this thing's a parallelogram. And we also want to show, we changed this as well, that this is not a rectangle. All right? So if we know we're going to do rectangle, one of the easiest things to do is just do the right angles. Just check for right angles. So what I'm going to do is I'm going to do the slope. Okay? Now once again, you can do the rise over the run from the points. If you draw the box around, that's up to you. All right? Or you can use the slope formula. So I'll just go through the slope formula for these points, and then I'll talk about the other one. But for AB here, remember we're doing y2, so I'm going to go B, so grab the 3, minus A, which is -2, and there's my double negative of the positive, and then we have -2 minus -6, and so here I get 5 over 4, okay? So the slope of BC, all right, so it's 1 minus 3, and then 3 minus -2, which is going to turn into those positives. So this is -2/5. We do the slope of CD, same thing here, -4 now, -1, and then -1 minus 3, and that's -5 over -4, which is really positive 5/4. So once again, those lines are parallel, and then we get the slope of AD, so -4 minus -2, which is really plus, so +2. And then we get -1 minus -6, which is really plus here. So this is -2 on the top. That's going to be 5 on the bottom. And so we have that going on. So you can see that these two lines, right, AB is parallel to BC. And at the same token, that BC and BC is parallel to AD. And we can just say the slopes are equal. We ought to make sure at some point we mention the slopes are equal. So whether it's here or when you write up your final statement, okay? So we're going to say A, B, C, D is a parallelogram, and then Y. So the opposite sides are parallel. And remember, that has to be because the slopes are equal. All right? Now, We don't even have to do any work for this, right? We already know that AB is not perpendicular to BC, right? Since their slopes are not opposite reciprocals. So we're good in that aspect right there. That part's done. All right? We can't just stop though. So now we say that ABCD is not a rectangle, right? We just say not all angles are right angles since consecutive sides are not perpendicular. Okay? And that's it. That's number 18 there. Number 19, so same thing. You're going to go graph. So over 5 to the left, and then up 2. So there's point B. E is negative 11, so 11 left, down 1. And the x is left 3, and then down 1. And so we want to find the area. Now, you have a couple options here. We can draw a box around the triangle, do the area of the box minus the area of the two right triangles that are left on the side there. Or, because these height base the side is a horizontal line, and the height just happens to be a vertical line, we can also just do 1/2 base times height and not have to worry about it as well. So it's up to you how you really want to go about doing it. We'll do both. Why not? So area equals 1/2 BH, which is 1/2, and then we got 1, 2, 3, 4, 5, 6, 7, 8. And then I'm just going to draw this line, as you can see it, that's 3. That's 1/2 8 times 3. So this is equal to 12 units squared. Okay? The other option, remember, is the box. So the area of the box is equal to 8 times 3, which is 24. And then the area of the triangle is 1/2. And you can see this is 3. And 1, 2, 3, 4, 5, 6. 3, 6, which is equal to 9. And the area of the other triangle is 1/2, 3 times 2. And so this is 3. And then we would do 24 minus 9 minus 3, which is also equal to 12. All right, number 20, rectangle ABCD has an area of 50 square units. The coordinates of A are given and B are given. Now here's the deal. If you look at the actual distance to get from A to B, okay, we can calculate this. So we do x1, so 5 minus 1 squared plus, and then we have negative 1 minus 2 squared. So this is equal to 4 squared plus negative 3 squared, which is equal to the square root of 25, which is equal to 5. So the distance of AB is 5 units. So I know if I looked at my graph, right, A and B, this has a length of 5. I need 2 other points, so when I do the distance between A and B and those 2 points, that I'm going to get here, okay, 10, because I need an area of 50, right? So if I already have a length of 5, the other side has to be a length of 10. So look at what the numbers are. I have, and it's got to be a rectangle, I have 15, negative 1, and I have 11, 2, so I have this. So the question is like, is that going to give me a rectangle? I have 11, 7, which is somewhere up here, and then 7, 10. And essentially that's what we're trying to do, is just figure out the distance between these points. So if we take the first one, and let's say we take the point 1, 2, and do the distance between this, the square root of, right, and you can see this is going to be 1 minus 15 squared plus 2 minus negative 1 squared. And this is 14 squared plus 3 squared. Is that going to equal the square root of 100? Because that's going to equal 10, right? And that's not. So that one's out. The other option is, what if these are switched, right? So what if we put the 5, the 1, 2 here, and the 5, negative 1 with this one? Would those give you a distance of 10? So if this is 5, negative 1, is this 10 units away? And if this is the point 1, 2, is that 10 units away? So it kind of helps in that regard too. So you can see that this is 10, that's a distance of 10. So that would work because you'd have sides of 5 units away this way, 10 units away that way. So that could be an option we choose. If you have a graph paper, this is another great option for it. Okay. And you will have this on the exam and on your test, so you can use this as well. Okay, so let's do something like this. All right, so 1, 2, and then 1, 2, 3, 4, 5, negative 1. So that's 5, 1, 2, 3, 4, 5, 10, 2, 3. There's 15. Okay, so 15, negative 1 is here, and then 11, 2 is there. Is that going to give you a rectangle? I'll let you look at that for a second. Rectangle? No, right? What about letter B? So what if we go 11, 7, 1, 2, 3, 4, 5, 6, 7, and then 7, 10. Okay, is that going to give us a rectangle? So, and are these lengths here going to be 10 units, right? So this is rise, run, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. Look at that, right? The square root of 8 squared plus 6 squared is equal to 100, and that's equal to 10. And if you look here, right, 3 and 4, we know that that from earlier is going to equal a distance of 5. So that will indeed make our rectangle. So that's an option for us right there. Okay? If we keep going along, let's take a look, and we'll do this one in purple here. So 5, 9, 3, 4, 5, 6, 7, 8, 9. And then 1, 12, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Look, that's not going to give us a rectangle again, so that's going to be out. 2, negative 5, 2, 1, 2, 3, 4, 5. And then negative 2, negative 2. And then this is going to be a square. That's not going to give us a distance of 10. So just using a quick graph paper is going to help you out immensely on this question. So make use of that, okay? Number 21. What are the coordinates of the point? Divide this segment from 2873 with a ratio of 4 to 1. So remember, this ratio of 4 to 1 tells us that our fraction, we want 4/5 of the line. So we're going to do the rise. From 2 to 7 is going up 5. And then from 8 to 3 is going down 5. So if we take 4/5, if we take the first, the x, change in x is 5 units. We multiply that by 4/5. That gives us a change of 4. And for the y's, which is negative 5, we multiply that by 4/5. That gives us an answer of negative 4. So we start with the first point. We take the coordinates of P, which are 2, 8, and we add 4 onto the x. We subtract 4 from the y, and that is going to give us our coordinates. And this is the point we're looking for. So that's 6, 4. Okay. 22, the endpoint of a segment is 7, 2. The midpoint is 6, negative 1. So we're going from 7, 2 over to 6, negative 1 over to another point. So what did you do to get from there to there? And then just do it again. So this is going down 1. We want to go down 1 more, which is 5. And here we're going down 3. So if we go down 3 more, we'll be at negative 4. And so that's the other coordinate. That is it for today. There's your review sheet answers. Hopefully that helps you out. Have a great night, guys.